Okay, number 15 has two cars. They start at the same spot, so we'll just call that spot right there. And one car 1, travels south at 60 kilometers per hour, and the other car travels straight west at 25 kilometers per hour. And they want to know how fast the distance between the two are changing. So see, as this goes on and this goes on, then your z, we'll call the distance between the two z. Z, how fast is z changing? So they want dz dt after 2 hours. So the first thing we need to know is that we need how far they actually went after 2 hours, and we get that from this 60 kilometers per hour. So we can say after 2 hours, this car at 1 went 120 miles. Nope, kilometers. And after 2 hours, car 2 went 50 kilometers. So we have our distances, and we are going to use the Pythagorean theorem to solve this one. So x squared plus y squared equals z squared. And what's really cool is everything's moving, so we differentiate everything in terms of time. So we have 2x dx dt plus 2y dy dt equals 2z dz dt. And we want dz dt. Now the 2's can all go away because we have 2 and 2 and 2. So if we divide by 2, everything goes away. And the x is going to be the 120 kilometers. And the dx dt, isn't that the velocity, right? So we would say the first one would be 120 times 60 plus 50 times 25 is equal to, now we need to know what z is, and it's after 2 hours. So if this is 550, 120, what is z? So z would have to be the square root of 50 squared plus 120 squared. So I'm going to just use my calculator, and that would be square root of 50 squared plus 120 squared, and I get 130. So z is 130 at this time. So 130 dz dt. So I get 7,200 plus 1250, right? So 50 times 25 is 1,250, and I'm going to divide that by 130. So I'm just going to use my calculator. So 7,200 plus 1250 divided by 130, and I get 65. dz dt equals 65 kilometers per hour. Let's hope that's what they got for number 15. Yay, we did it right. Okay, I'll pause and do number 17 too. Number 17 is about the altitude, it's about a triangle, and it says the altitude of a triangle is increasing at a rate of 1 centimeters per minute. Well, I drew a triangle, so here's my triangle. And the altitude, to me, is basically what we call the height. Depends, they call it the altitude because sometimes it's outside in geometry. They call it the altitude, not necessarily the height. But I'm going to use height for altitude, and there's the base, okay? And it says that it's increasing at a rate of 1. So I said we have dH dt, that's the altitude, is 1 centimeter, changing 1 centimeters per minute. the area of the triangle is increasing at a rate of 2 centimeters squared per minute. So that means we have dA dt also. So 2 centimeters squared per minute. And it wants to know what rate is the base changing when the height is 10 and the area is 100. So this when part comes after we take the derivative. So what kind of formula we're going to use? The area of a triangle, right? Area equals 1/2 base times height. So we'll take the derivative. dA dt is 1/2, and we have to do this explicit using the product rule. So 1/2 the derivative of b, which would be dB dt, plus, times h, plus the first 1/2 b times dH dt. And now we substitute in what we had. So we had dA dt was 2 is equal to 1/2. We want dB dt, but so we're going to use dB dt still, times h at the time we're talking about, so that's 10, plus 1/2 b, the base. Now, we don't have that, but we have the height and the area, so we're able to calculate what the base is at this time. So at this time, A equals 1/2 base times height, so 100 equals 1/2 times base times 10, or 5b equals 100, so b is 20. So I can use 20 for my base, and then dH dt we were given as 1. All right, so we're going to calculate this. Let's simplify it. 2 equals 5 dB dt plus 10. So we'll subtract and we'll get -8/5 is equal to dB dt. Okay, let's pause here. Let's think about units. This was in centimeters squared per meter per minute. So this would be -8 centimeters per minute. -8/5. By the way, that's -1.6. 8/5 is -1.6 centimeters per minute, which is what the answer was on the answer key. So that was number 15 and 17.